Hi guys, so in the last tutorial of linked list series we talked about how to delete middle node of single linked list. Now as a part of this tutorial we're gonna talk about how to delete last node of single linked list. So let's get started. Now as you can see we have already created one single linked list with 5 data nodes and we have to perform delete operation on last node of this list which has data value 50. And to do that we have to traverse each node of this list until we'll not reach to the second last node, because from second last node only we're gonna delete the last node of this list. So for that we have to take a help of one pointer which will be initially pointing wherever head is pointing, and on each iteration this current pointer will move one step forward based on the while loop condition. So what this while loop condition is, current.next should not be null, then only it will be moving one step forward. So let's evaluate this condition and move our current pointer one step forward. So what this condition is saying, the second node from this current pointer should not be null. So this is the current pointer, this is the first node of from current pointer, this is the second node, so it's not null because we have data value 30. Now this condition is true, it will come inside this while loop and execute the statement of while loop. So what this line is doing, basically this is taking care of moving our current pointer one step forward. So let's execute this. Now you can see our current pointer is start pointing to second node of this list. Now again it will check whether current.next if it is null or not. So what it mean, the second node from current pointer. So now current pointer is this, and this is the first node and second node from current pointer. So this should not be null. So this condition is true because we have data value 40 and it's not null. So this condition is true, it will come inside the while loop and move our current pointer one step forward. Now you can see it start pointing to node which has data value 30. Now again before moving one step forward it will check this condition whether it's true or not. So second node from current pointer, so this is the first node and this second node, should not be null. So as you can see the second node from current pointer, it is not null because it has data value 50, and this condition is again true, it will come inside this while loop and move current pointer one step forward. So let's execute this. Now as you can see it start pointing to another node which has data value 40. Now again the same process we have to follow, current.next should not be null. So let's check whether the second node from current node is null or not. So this is the first node and this is the second node, means the second node from current pointer is pointing to null. So right now current value next is null. So this condition is false because we are expecting to not null, then only we will be moving current pointer. Now current next is pointing to null here, right? So this condition is false, and when and this control will exit from while loop, and when the control exit from while loop at that point our current pointer will be pointing to second last node of this list. So as you can see it's pointing to second last node. Now our next job is we have to initialize the reference of second last node to null, and the link between second last node and last node will no longer available, and the last node will be applicable for garbage collection. So that job is taking care of this line of code. Current.set next means we are reinitializing the reference of current node to null, right? The current is second last node and the reference we are initializing to null, so it start pointing to null, and this will no longer available, this will get deleted automatically. So after executing this line of code, the remaining nodes will be 10, 20, 30 and 40, and the 50 node, which was the last node of this list, is no longer available, it got deleted. So this is the graphical representation discussion. Now let's get started with backend code. So for that, I have already created one class with name delete node from end. Inside that, we will be writing a logic to delete node from end of the simply linked list. So let's get started. Private void and method name will be delete from end. It will not have any parameter and we have to create head node first. Private node head. So our first step should be, we have to check whether this head is null or not. Objects dot non-null of head. If it is not null, then we will be creating one current pointer as we discussed, right? Node current. So it will be exact copy of head. Now this current basically we are using to traverse each node of simply linked list as we discussed in the graphical representation, right? Now we have to check whether current.next is null or not. Why we are checking that, I'll explain you that as well. So let's say if we have if there are no any node available, right, at that point what we're gonna do here, because head is null, so at that point we will be writing one message as out linked list is empty. This is the message which we are printing if there are no any nodes available, right? But if there are node available but only one node is there, right? So at that point what we have to do, we will be just, because we have to delete the we have to perform delete node from end, right? So this is the node which is a first node of simply linked list and also last node of simply linked list, because we have only one node. So this will be a first node and last node as well. So now we have to delete this node, but before that we have to check whether objects dot it should be is null, right? So we will be doing current dot get next. We know that we have some data in current, right? But if in current we have value 10, so we are checking the reference of current, means the current value is pointing to any node or not. If it is null, means we have only one node, right? So at that point we have to directly reinitialize the head to current dot get next. So get next is already pointing to null, means current we have value 10, this one, and get next means reference is pointing to null. The same reference we are assigning to head, means now after this operation head will be start pointing to null. This will no longer available. So this line is doing just removing the first node from the first or last node from the list linked list, because there will have only one node and that node will be first or last node. So that operation we are handling here. If there are multiple nodes, right, if this condition is false, so it should be next, not data, sorry, by mistake I have added data here. Now the next job is, actually this looks little bit messy. Okay, now next job is, if there are more than one node available, like 10, 20, 30 and 40, as we discussed, till 50, and 50 reference is pointing to null. Now we have created one current pointer, which will be pointing initially wherever head will be pointing. Means head will start pointing to first node of syncly linked list. So we have done the same here, right? Now head is pointing to first node of this list. Now we have to traverse this, right? So let's use while loop, because we have to reach second last node of this list. From here only we're gonna delete this node, so we have to reach here. So let's write while condition objects dot non null. So as we discussed here, right, as we discussed here, we will be checking the second node from current pointer. So current pointer is this, we'll be checking the second node. Second node is this, right? So we have to check current dot get next two time, right? So what we're gonna do here, current dot get next. Okay, now if this condition is non-null, we are already handling this. If this second node from the current pointer, if it is not null, then we will be moving our current pointer one step forward with current dot get current is equal to current dot get next. Okay, now let's evaluate this. But before this, what happened when we exit from while loop means this condition is true. This condition is true. At that point we will be moving our current pointer one step forward. But what happened if this condition is false, right? If the second node from current pointer is pointing to null, at that point our control will exit from this loop, right? So we have to reinitialize this, right? Let's execute this first. So then only we will be reinitializing the second last reference. So in first iteration, let's move this. Can do one thing, I can use I can run in debugger mode, but there is no any main method created yet. So in first iteration we will be checking with current dot next means current is this and the second node from current is 30. It's not null and this condition is this while condition is true. Okay, and it will come inside this while loop and the statement of while loop will be executed. So this line will moving our current pointer one step forward and it will start pointing to this node, right? Again it will be checking whether this condition is true. So what this condition is doing, this condition is checking the second node from current pointer, which is 40 is null or not. So it's not null, again we will be moving current pointer one step forward. Now in third iteration we will be checking whether second node from current pointer, so second node is 50, right? So this condition is again true because we have second node and it's not pointing to null. So again this condition will be true. It will come inside while loop and move current pointer one step forward. Now we have to check whether again this condition is true or not. So the second node from current pointer is this is the first node and this is the second node, means this is pointing to null. Now current value will be current next is pointing to null and this condition will be false, right? So control will exit from while loop and now as we discussed, if the control will exit from while loop, at that point our current pointer will be pointing to second last node. So you can see it's pointing to second last node. Now from here itself we have to delete the last node, right? So that code we're gonna write here, current dot set next, and we are setting it to null. Now what we are doing here is, so current pointer is pointing to second last node and the reference of current pointer is we are setting as null. So now it will no longer pointing to this node, instead it will start pointing to null, and Now there is no any connection between second last node and last node, so this will become abandoned object, and this last node will be applicable for garbage collection, so it will automatically get removed from the list. Now this is the use case. Now let's write a main method for this and verify whether our logic is working fine or not. Main. So let's create object of this current class. Delete node from end. List is equal to new delete node from end. Now let's create multiple nodes, but we have to check the first scenario, right? List dot delete from end, right? Let's execute this. So there is no any nodes available, so at this time we should get this message, linked list is empty, right? Because there is no any nodes available. Yeah, linked list is empty, right? I can show you in debug mode, it will give you more visibilities, but before that I have to add debugger here. Debugger is here. Okay, and it will come here, right? I have to check this also. Okay, let's run in debug mode. Now you can see head value is false, right? Head is pointing to null, so this condition will not true. And let's run. You can see it's directly going to else block and printing linked list is empty. This is the expected behavior. You can see here linked list is empty, right? Now let's add one node. So adding multiple nodes. So let's add node here. First node is equal to new node which has data value 10, and we will be connecting these node with head. Nodes together to frame chain. Now let's connect these lists together. Dot head is equal to first. Now we have only one syncly linked list with one data node. Now let's print this. Sorry. So printing all the nodes, all the elements of singly linked list. All right, now we have already created one class with name print or display. I forget the name. Print linked list, which has display method and which is expecting head of node type. So we have built this printing list method, printing list class having display method in earlier tutorial. You can go there and watch these another videos as well. So we will be printing this, and after performing this operation we will again printing the same elements again to verify whether it's working fine or not. Now you can see we have only one list created and after performing delete from end, we have deleted this node, right? And it's right now we have only null. So this is the second scenario, right? The first scenario is when there are no any nodes available, so it should print this message. And the second scenario is when there are only one node available, so we have to delete that one node as well, because that one node is a head node, a first node of syncly linked list as well as the last node of syncly linked list. Now if there are multiple nodes available, right, at that point we have to handle that scenario as well. So we have handled that. Let's verify that scenario as well. Let's add 4 more node, and the data value will be 20, 30, 40 and 50. Second, third, fourth, fifth, right? Now let's add these newly created node in the linked list chain. So first dot set next will be second, and second dot set next will be third, and third dot set next will be fourth, and fourth dot set next will be fifth. So this fifth is the last node, and by default fifth reference will be pointing to null. Okay, now let's verify. So you can see we have created this list, right? So which has data value 10, 20, 30, 40, 50 and 50 reference pointing to null. So this is the last node, right? And after performing delete from end operation, the remaining nodes are 10, 20, 30 and 40. So this was the last node of this list. Now it got removed here, right? And now second last node become the last node of this list after performing this operation, delete from end. So so our logic is working fine, and we have done with this video, guys. Thank you so much for watching these videos, and stay tuned for another videos. Thank you.